greatest mysteries that has baffled the human society is about the space, and there are like a certain number of satellites that actually try to give us more explanation about the mysteries that revolve around us, or should we say that we are a part of it. We have Sathyan Krishnan. Thank you so much for speaking to us, sir. He has been a part of Hubble Space Telescope and James Webb Telescope, both very important instruments and machines that actually show the humanity about things that are beyond or like at infinite space. Thank you so much, sir. So give us a small introduction about your work with Hubble and James Webb.
So I joined the Hubble Space Telescope in 1997, which the telescope actually launched in 1990, and I joined about 7 years later. My job on the Hubble Space Telescope was I was a pointing control engineer, and we needed to make sure that the telescope in orbit was working all right and the astronomers could point it towards the targets they wanted to observe, and that the telescope was steady to the extent they needed it to be to get some of the wonderful pictures we have seen. In addition to that, the pointing control system makes sure that if something goes wrong, if a reaction wheel breaks or if a gyroscope breaks, that the telescope is maintained in a safe attitude, that it does not suddenly go and point towards the sun, which will destroy the optics in the system. So that was in 1997. In 2004, I joined James Webb Space Telescope with Northrop Grumman in Los Angeles, and that was the start of the James Webb Space Telescope. It was designed from the ground up at that time, and I was eventually leading the attitude or the pointing control system, where we made sure that the telescope points to where the astronomers want it to point, and that it's held steady, and that again it is maintained in a safe attitude so that it doesn't suddenly point to the sun or the earth and destroys the optics again.
What is the actual work of James Webb? What does it look into, and what are the data it collects?
So just to contrast first with Hubble Space Telescope, the Hubble Space Telescope is optimized for visible spectrum. That is our typical VibGure: violet, indigo, blue, green, orange, red. And so it is essentially the light that we can see with our eyes. The James Webb Space Telescope, on the other hand, is optimized for near and mid-infrared. So it is beyond red into the infrared region. So it's a longer wavelength or shorter frequency, if you will. It is something that we cannot see with our eyes, but it is something we can perceive as heat. And so the reason the James Webb is optimized for infrared is that as objects move away from each other, visible light that is emitted as visible light will be seen by the other object as a longer wavelength or a smaller frequency. And so visible light that comes from a star that's moving away from us, we will see that if it's blue light from that star, we'll see it as red or even infrared. Okay? So James Webb Space Telescope is designed to look 13.5 billion light years into the past. Okay? And so at that time, at the Big Bang, we had a big explosion and everything started moving apart. So if you want to look at what happened back there, that is moving away from us at a very high velocity. And so visible light emanating from that time, which is reaching us only now, will appear to be infrared, which is why James Webb is optimized for infrared.
We've seen like beautiful pictures collected by like James Webb, and some look like should I call that Eagle Nebula or Horse Nebula and such. So what is a nebula, and why are we concentrating on these collection of gas mass or stars?
So to some extent, a lot of the pictures we see are more for public consumption. astronomers don't care about the colors and how pretty it is and all that. But what the colors do indicate to the astronomers is what is the composition of the particles there. Is it hydrogen or helium, or is it a heavy metal dust? So when a star explodes, it sends out, explodes, and there's a lot of dust and energy that's emanating from that. And observing the nebula, looking at what is the frequency of the light coming from it and so on, tells us what the composition of that dust is and so on. And one advantage of the James Webb Space Telescope is that it is observing, like I said, in infrared. If you have dust and so on, visible light cannot pass through it. It gets scattered and blocked, whereas infrared can pass through it. So we can actually look behind the dust clouds to see something that's further away, or what is at the source of the dust cloud. Like, is there a black hole, or is there a star that's collapsed, or whatever it is behind it. So that is the advantage of the infrared. That's another advantage of the infrared.
Can I call it as a way we are looking into the past, or like how is it?
So actually, James Webb Telescope is also called a time machine, because we are looking back into the past 13.5 billion years ago. So we are trying to look.
Is it light years or just years?
So it is years. So the distance is light years. So the distance that light takes to travel in 13.5 billion years, that distance is called light years. But the time it took to travel is actually 13.5 billion years. Okay. So the Big Bang, one of the major accomplishments of the Hubble Space Telescope was that they determined that the Big Bang happened 13.7 or 13.8 billion years ago. And after the Big Bang, there was a period when it was total darkness, according to our Big Bang theory. And then you had reionization, and then the first stars and galaxies started forming. So one of the major objectives of the James Webb Space Telescope is to observe how those initial stars and galaxies were formed, and based on that to get a better understanding of how the whole universe was formed and so on.
So like we know that in the James Webb Telescope, just like you mentioned, is using infrared frequencies to collect data. But how does that exact the telescope machinery work? What kind of mirrors do you have in it, and how are you collecting the data?
Okay. So the Hubble Space Telescope had a 2.3 meter mirror, so probably about this tall. Okay, the James Webb Space Telescope has 18 1-meter mirror segments put together, and so the total height
bigger.
is about 6 or 7, about 7 meters tall. Okay, and the collecting area is about 25 times the collecting area of the Hubble Space Telescope. So the Hubble Space Telescope was able to look back to about 12 to almost 13 billion years ago. The James Webb Space Telescope, because it has such a big collecting area, is able to look back to 13.5, 13.6 billion years ago. And what it has in the back are instruments. There is MIRI, which is the mid-infrared imager, and then you have near-spec, which is the near-infrared spectrogram. So it actually looks at, the spectrograph essentially takes the light and splits it into frequencies. So it tells you what frequencies of light is emanating from something. An imager just takes a picture of an object or of the sky. Let's see, we have MIRI, near spec, we have near cam, near infrared camera, and then we have one more instrument. I forget the name.
So
of
in
it.
a way, we are getting these towards Earth, these particular frequency of light that has emerged almost 13.5 billion years ago. It's still passing through.
Yes. So if we look at the sun, it is putting out light in all directions. We are seeing only a part of it. The light we are seeing from the sun actually emanated 8 minutes ago.
Before it reaches Earth.
Before it reaches us. So the nearest stars we have, I think, are like 4,500 light years, I think. I'm not exactly sure of the numbers.
Alpha Centauri or Andromeda?
Andromeda is a galaxy. I think Alpha Centauri is about 4,500 light years away. So what we are seeing of Alpha Centauri is what it was like 4,500 years ago. So when we look at objects near the Big Bang, we are looking back in time to see how things were when the first stars and galaxies were formed.
And why is that this kind of be it Hubble or be it James Webb, why is it necessary for the future? We are looking into the past for the future.
So it is, man has always looked up at the stars and wondered what is out there, who is out there, why are we here, and so on. So this is very fundamental science. Okay? So fundamental science, it is difficult to say what are the benefits of it now apart from just gaining knowledge. If we understand how things work in stars, I don't know, maybe it'll help us design better nuclear reactors. Or
power sources.
Yeah, or I don't know. So I can't think of any immediate benefit from understanding science. I mean, understanding the basic physics of these things. But the technology that went into this has direct implications for us. The detectors they had to develop and design for this can be used in our everyday life. Infrared detectors can be used to see what's happening behind this wall or something like that. And and then they built a large sun shield to protect to keep the telescope cold, protected from the sun, and that's like 2-micron thick mylar, and that can have a lot of implications for insulation on the ground, for thermal management. Maybe eventually it'll be used to keep our house cool or warm or whatever, to maintain the temperatures in our house, which can save energy and so on. So if you, someone was mentioning the other day, if you go on Google and see spin-offs of space, you will see what are the benefits that came out of the space program, not necessarily directly from learning about space, but from the endeavor technology. So like Velcro that you used to, that came out of the Apollo program. Teflon that's on your non-stick pans, that came out of the Apollo program. So there are peripheral benefits, and it also injects a lot of money into science and technology, which has obviously a lot of spin-offs.
Betterment for the human society. Yes. And keeping everything together.
Yeah.
That was Professor Sathyan, and thank you so much for speaking to us, sir.
Most welcome.
The important aspect is that collection of information is very important. There are various implications to it, but the most important fact is that one thing the human society has always wondered about is where did we come from? Is there any other planet or source where we can find a civilization that is like human beings or so? So everything science answers, and one way to find about our past, to know about our past, is Hubble and James Webb Telescope. This is Deviraj, Pramod Madhav for Eastern.